Oh, I forgot. I had to do an intro. How do I do that? Okay. I don't have like a whole intro thing. So let's see. All right. Hi, Blackjack Fitz here. That's so awkward. I can't do that. I can't do like a weird awkward hi. All right. Hello, this is Blackjack Fitz, and today's puzzle is going to be Finding Your Marbles by The Pedaling Pianist. Let's take a look at the rules here. We're going to divide the grid into orthogonally connected 5-cell regions. Marbles join cells that share a region, and no two marbles share a region. Right, so we've got like a chaos construction 5x5 thing going on here. So I think that's going to be, so we could do something like, that's a region, and then I think like that could be a region, maybe. Something like this, right? I don't think that does work, but you get the idea. You sort of draw your own sort of different regions in there. But we do know that these start different regions. So actually, even before I move on with the rules, I think we'll just begin by coloring these here. Next, we're going to draw a marble run from any cell in the top row to a 3 in a corner. This marble run will be formed entirely of L-shaped line segments, a downward movement to gain speed, and then a horizontal movement of the same distance. Adjacent cells on the marble run are in different regions. That's interesting. So we'll start like here and then go down, and we can go like here and then go down and go here and then go down and then go here and then, or yeah, something along those lines. Well, to a 3 in the corner. So yeah, so we'll end up, one of these is a 3. We can actually do that. I think by rules, we'll know that there's going to be a 3 down there. So that's exciting. We'll have to be ready for that. Okay. So, and then what it said was, so for example, we can't go from here down because adjacent digits all have to be in different regions, I think is what it's saying. Yeah, adjacent cells on the marble run are in different regions. Hey, Sarah, welcome. Good to see you. Oh, not Siri. That's weird. Okay. At this point, the regions reveal a cryptic hint about the nature of the marble run. Use this to solve the puzzle as an irregular 5x5 Sudoku. So what that means is we're going to have to create these 5-cell regions in some shape, and we'll place the digits 1 through 5 in every region that we draw, plus every row and every column. And apparently there's a cryptic clue that we'll get out of the drawing of these regions, or the marble run. And that's all the rules. So I'll post a link to the puzzle in the video description. Let me know how you get on. I feel like awkward. I don't want to steal all of Simon's things. But yeah, so you can try the puzzle and leave a comment with how you enjoyed it. But now I'm going to try it. And I've got some help from the chat, from Twitch chat here. So if I'm looking off over this way, that's what's going on there. Right. So I think I can leave all of these notes that I sort of left in because I think they were all correct. As far as these have to be in the same region, right? And then, but so what we know, Sarah, I think because it says in the rules, draw a marble. So the question was, wait, why is there a 3 in one of these cells, pencil marked? And that's because the rules tell us that there will be a 3 in the corner somewhere that the marble run ends in. Right. So how can this work then? This one we can tell straight away I think can't be, it has to get speed from, I think it has to start by going down, right? It can't start by turning. Otherwise, it would just start in that cell. So this one's not the start of the marble run, but this one could be. Maybe we have to think about how it gets out. I guess it could just drop straight into a corner, but I think it might be able to do this. It gets speed and then turns. So I don't think we know that for sure. Let's see. I'm really actually unsure how to start this. It feels like maybe we have to think about, well, there's one color that isn't in the grid, right? That could be red. Hey, Marty, welcome. So we have one more color that we haven't identified so far. And I'm not sure. So it could be something like up here, or it could be something down here, or it could be something, weird like that. But I mean, I can see like this. Maybe I need to like X out cells that aren't on the marble run, because that's not on the marble run, because it would be dropping down into its same cell. And I don't think this can be on the marble run, because if it was, we would be having to turn like here or be turning like that way. So we'd be taking both of these cells. Now, that's not true for this one. I mean, I can see that it can't do like that kind of thing. So if this was on it, it would have to go like that. It's going to be really tricky, actually, to make sure each of these okay, so I'm seeing Helio in the chat saying the path travels along an even number of cells. It goes down and then horizontal an equal number of times. So like 1, 2. Oh, sorry. 1, 2. 1, 2. 1, 2. 1, 2. Okay, so then it does need to make a so it can't come down here. So it's either one of these two cells is on the loop, because it's got to be like this then, I believe, which means one of these two is on the loop. So that's interesting. It's sort of got this kind of like I feel like there's a oh, okay, so we don't know that. Sorry. All of the other moves are 2. Sorry. Okay, so I was we're not sure. We don't know that it comes down and has to do that. All right. But we can say that I think at the start there's going to be something interesting about that. So I wonder if it can just end here. Let me reread the rules. Marbles join cells that share a region, and no two marbles share a region. Okay. Draw a marble run. Draw from any cell in the top row to a 3 in the corner, formed entirely of L-shaped line segments. A downward movement to gain speed, and then a horizontal movement of the same distance. I think it does need that. Oh, is that true too? Oh. Yeah, so, okay, so that's an interesting, all right, So Helio is suggesting it might be able to go down 2 and over 2. Is that right? That's an L-shaped line segment, a downward movement to gain speed, and then a horizontal movement of the same distance. Right. So that is true. It's very clear, actually, now that I read it that way. Good. Okay. So thank you. It could even potentially do like that. Right? 1, 2, 3, 1, 2, 3. So I wonder if like that's, what if it was the marble run? That would be quite weird. But I think that that's within the rules. Wait, no. No, that's not in the rules. But like this could. except that I think each of these would have to be in a different. I mean, that doesn't work for a number of reasons, but I don't know. You get the idea. Maybe I need to like X off like places where it can't travel. So it can't, the line can go into this cell, but it would have to like leave. Or it could go like this and then go down and then this and that and this and that. Ooh, this is tricky. Yeah, I don't think 5 by 5 works. I don't think we can do that. If for no other reason than this doesn't have a partner to get out, can't make a region, since both of these would have to be different. Okay, so we're seeing it probably has to start in an odd column as from the chat. Let's see if we agree. If it went here and went doot 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 doot. Wait, well, why not here, 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 here? Now I think we agreed that it did have to turn at the bottom, right? Because that's not an L-shaped segment. This is an L, and then that's an L, and then that's an L, but that's just a vertical. So that wouldn't be L. So I think you're right. It does need to be, I think I agree with that. It does need to be, this last little bit has to wiggle on the bottom. I want to think that that's true. That's how I'm reading the rules. So I hope that that's right. That it needs to like when it comes down, it needs to turn. Otherwise it's not an L-shaped region. Like if it did this, then we've got an L there, an L there, an L there, but that's not doing the thing. So it's got to come in from the side, basically, however far down it went, something along those lines. So what that means is if we tried to start an even numbered column, 1, 2 over 2 down, now we need to go down 2 and over 1. And that's going to be the same if you flip it, a different direction. 1, 2, 1, 2. Now we need to go down 2 and over 1, and it doesn't work. And we know that that's not in it. So one of these two is, I believe, well, actually the correct way I think using notation would be to do this. Right. And we can exclude this cell. That's true, because and this one too. And I think we'll probably be able to do that here also, right? Because yeah, we're going to end up with this pattern here, I think. Is that true? Well, I guess the X's now mark where it can't drop down. So that doesn't mean it's not on the loop. It just means that you can't have a downward movement from there. So, or that's not, what's the way to, I don't think that that's right, actually. I mean, there's something about that. I think that there's something about that. Because it can't end here. I guess it's going to take one of these two cells, right? And it's going to take one of these two cells. Or it can do the 2 thing. Yeah, moving down multiples is the tricky part here. Correct, Helio. I was trying to extrapolate from it. It definitely doesn't go in these ones. I think I'm very comfortable with that claim because, well, I guess it doesn't drop from here. Yeah, the notation's tricky. Because I think it could do that and then down. Like the line could go, I imagine, like this. Like that, I think, is all L's, right? So that's an L. that's an L, and then that's an L. So that doesn't mean it's not visiting there, but it means it's not dropping from there. But how does that work up here? Like there, because I guess it's not starting a drop from there. Is that the way to think about it? Hey, Riff Clown, welcome. I think Skojo. Hello, everybody. Ooh, what did I do? Right, so I'm doing one of Stu's puzzles right now, finding your marbles. And I'm very intrigued by it. But I'm having a hard time wrapping my head around it a little bit, in a very good way. So, because what I want to do is this, right? And say this isn't a downward cell. But of course, what I mean by that is I could pass through here in an L, but I can't start an L there. So I could pass through an L there too. That's fine. You can pass through it, but you can't start dropping down an L from those positions. And I think that's going to be true for like here too. Because I can move through it, but I can't start an L there. That's not going to work. And I think that's true here, here, and here as well. Hold on one second. Perhaps use a different color for dropping cannot enter the cell at all. I was thinking that, but like because I'm using colors to distinguish the regions. Oh, you're right though. I should do. What can I do? Yeah, because that is true. I have a stronger case to be made on a few of these. So what I'll do is I'll switch to like gray. So it can visit those cells, but it can't start dropping down an L. Or the O's would have worked too. That might have made more sense. But in any case, I don't actually think it can visit here, this cell. See, now I'm all like thinking I should do it in O's because I don't want to be switching colors all the time. Can it visit this cell at all? I don't think so, right? Because it would have to have come down through here. So that's just a stone cold X. That's off the marble run. And I want to also do like, yeah, I guess I'll just use a green run when I actually know it. Row 4, column 1 is also gray. That's true. These are, yeah, we proved that could be. Yeah, the only ones that we know for sure can't be on are these ones in the top here. So one of these two is going to be, one of these two cells is going to be, so now if this drops down, actually it can't go that way, can it? So how could this ever be on it? Because adjacent cells along the run have to be in different regions. So the only way to get into this is through that region. So that's not on the loop. So if this goes, it's got to go like that. And these have to be all different regions. Or it could just go, or it could do that. I take it back. We could do a big L. That's within the realm of possible. If it's this one, then this has to be in a different region from it, which means that these would have to be in the same region, at least. And then unless it went down again, how would that work? That would mean this had to grow this way. This had to grow this way. This could grow into red. And then this, I don't know, maybe that could join up with that. I'm not sure. Tricky. Right. So what's going on with this one? That one could, well, that one can't start a downward region either because of the sort of coloring, right? Because let's say we did like that. The circles just mean you can't start a downward L-shaped region, and that one can't start a downward L-shaped region because these two are the same regions, and it would have to be adjacent. Maybe I think what I'm not appreciating is the fact that the adjacent cells on the run have to be in different regions, and that's probably a lot more constrained than I thought. Like if yeah, if like let's say it did this, then this has to be red, but that's actually okay, isn't it? I want to just do a little doodle here. So let's say we did like this. Then we would know that this had to be red. And then this would have had to have come up. So that couldn't be red. And this can't be red. So that would have to be red also. I'm wary of venturing too far into bifurcation land, but I'm just want to try to get my head around the restriction on different colors. Hey Isaiah, welcome. Let's see. How can row 3 column 5 drop down? Row 3 column 5. This can't be the start of a L-shaped region, can it? But it could. No, I don't think you can do, because we already agreed you can't do this. You can't do a 1. Can't do a 2 from there. Well, it would have to go, yeah, it would have to do that. Yeah, I don't think that can drop down, can it? That can't be a drop down cell, which means I think over here, does that mean that this has to be on our loop, the green one? As soon as 2 line segments are different lengths, it breaks. Yeah, I think maybe you were referring to how I was kind of pencil marking stuff over here. I don't know, unless there's something more to that. But I do think that this is interesting now because we have, none of these can start L's. So that means, could we have something that does like this though? And we don't actually need that. I'm not sure that that's not a good mark. Because we could, I think, have like we could have a line that does this and then goes down 2 over 2 and then like that. And I think that that's within, and that's not doing anything with this cell over here. So maybe we need to actually prove that that has to happen. Maybe this one can't be this. How would we get to here is an interesting question. How could this be on the loop? We could do like this, I think is the only way, because we can't come down from here. This is never on the loop. So I think the only way that gets on is if we do this. And then we would, so actually it would be very forcing. For this to be on the loop, I think it has to do this. That's the only way. And then what does that mean? This cell now can't be that one. So these two have to be the same cell. This has to go that way. This can't. Oh, that's broken. It's broken in the corner because these two become a region. But now it can't go there and it can't go there and it can't go there. So that's broken. So actually, I think we can just rule out that at all. But more broadly speaking, I'm worried that that's not the cleanest way to prove that. See, oh, that's interesting. Helio is saying, can the run ever reach row 5, column 5? I'm wondering if it can ever do this. I think what's actually going to happen is we might have to... Oh, it can do something like that. But I think that this one's off. I don't think that that's on. Is there any other way it could get there? None of these are on the loop. So it would have to come from all the way over here, which means it has to go from there. And that is broken. I'm convinced that that's broken because this gets trapped in by the fact that it can't take that cell, or that cell in this 2-cell region. So that's not on the loop. Which means actually none of these are the start of L's. So we're definitely getting a big L coming down through from the second row. And that, I think, has to start here, doesn't it? These 2 cells aren't on it. I think this has to be on it. And it's got to go down to over to... I think that's it, actually. Now, I don't know how it closes. I think that that's all forced. Because we've proven that this can't be the start. This cell can't be the start of a downward. This one can't be the start of a downward L. And these 2 aren't on the loop at all. So this has to be... Yeah, I think that's all forced. And that gives us... Oh, I think our first... I hope that that's a good proof, but let's do our 3 in the corners here. I think that that's legit. Now, the only thing I don't know is whether it goes like that or like this. Now, I probably do if I give it a little bit of thought about the coloring. But yeah, I think I can do away with all of my marks here though, because it's gonna. Hope I have that right. Otherwise, I'll have to go back. We'll have to start over. But that all felt good to me. And we just need to it's gonna either do this. I kind of want to start reading into the cryptic and see like what do I think it means. Well, isn't it? So if it goes, I'm guessing, is this like it's pointing to something? I don't know. I don't want to read into it too much until we we actually think through a little bit more. We do have a lot of region borders now. I think that's probably a wise way to do it here. Oops, let's do it in black. So loads and loads of region borders. So this goes up. I don't know if that's something. I'm going to go ahead and just make it purple now, knowing that it could potentially grow to something. This now grows. Again, I don't know. Raffle, welcome. Oh, Raid, cheers. Whoa, nice. Oh, wow. Welcome in, everybody. Big old group coming in. Cheers. Very nice. I think we just had a big breakthrough here. In terms of how this marble run puzzles. We're doing one of Stu's here. So, yes, let me look at Helio's comment here. It can't be red and it can't be a 5th. This one has to be yellow. I think I agree too. This can't be just 4 on its own, and it can't be 3. If it to be red, it would have to do that and it would isolate this cell. So correct. That's not black. That's yellow. So now this now I think has to be red, doesn't it? Because it can't join yellow, and it can't be another thing. Sorry, excuse me. This one I think could be the last yellow. But even if it's red, that has to be red to get enough cells. Now, what's this? It could be, it's yellow. I think this is a yellow-red pair, which fills all of these digits. So we can draw some more borders in here. And I will wrap the whole perimeter. Oops, I think that's all legit. Now, Finish pink. I don't know that pink's a new color. I don't think. Pink, I think it could be blue, for example. I'm not sure. I think we're not quite ready. The row 3 cell isn't red. If that was red, the loop breaks. Thank you. Good spot. Now, should have been obvious. That's why I put that line border in there. Okay, right. So there we go. And that's going to be not yellow. Cool. Thank you. Right. So we've got 2 regions in. I don't actually know that this is a separate region yet. So I don't think I can just do that with purple. In fact, we're going to have some issues here. If it goes this way, then that cell is trapped now. So actually, it can't go this way because then this cell wouldn't be able to get any partners. So I think, no, our marble run's going to go like that. And now we can do some more line bordering because we know that this and this are different regions. So either this is a whole new region up here. In fact, I think it must be. What's this, right? It's not green because it would have to wrap around. It's not red. It's not yellow. So this isn't a new color. This is going to be blue, I think. I think this is just straight blue. And then this is going to be green, and this is some new color. So that's going to be purple. This is blue, and that's green. Is there any other way to do that? I think that was pretty solid, right? I feel good about that. We'll see if anybody says see if anybody has any objections to that in the corner. Okay, so now at this point, the regions reveal a cryptic hint about the nature of the marble run. Use this to solve the puzzle as an irregular 5x5 Sudoku. Right. So my first thought was like what is that? Y, P, Z, P? I don't think it might. My first thought was maybe it was the shape of, or like the letters associated with the different pentominoes. They would do it, but maybe it's not. It's got something to do with like turning my head to see what's going on. What is so? It's a cryptic clue. Let me read that section again. Adjacent cells. No, at this point, the regions reveal a cryptic hint about the nature of the marble run. A cryptic hint about the nature of the marble run. Use this to solve the puzzle as an irregular 5x5 Sudoku. Okay. The regions reveal. So I mean, maybe it is. Do I know these? What are they? This is P, P, Y, zippy. Oh, it's a zipper line. That's great. Nice. Oh, that's cool. Zippy. Okay, so let me explain that. This is called a Z pentomino, or Z for my fellow Americans. That's cool. That was awesome. Okay, that was my first instinct actually, but I thought that it would have to read in a particular order. That doesn't make any sense. Okay, so this is a Z, and then this is an I pentomino, and then this is P. You can kind of see it. I'll do it in black. Like that's the P, right? And then this is the same down here, and then we've got a Y. So this one's kind of mirrored. It a little bit easier if you see it at different direction. If you imagine it sort of mirrored around, but that's the Y pentomino. So we get zippy. So I think we're meant to assume that this line is a zipper line. That is freaking genius. I love that. Okay, so 1, 2, 3, 4, 5. Yeah, so this is the center of the zipper line right here. So what does that mean? We're going to have 3 cells in this region that are on the zipper line. So I don't think, I mean, that's for sure a 4 or a 5. If it's a 4, then you would need to have, this would have to be 1, 3. And this would have to be a 2 with a 2. Actually, that could work. Yeah. Lots of people in the chat loving that. That was really, I mean, that's incredible that you could do that. This is a remarkable construction. Absolutely remarkable. Yeah. Wow. Okay. Let's focus on trying to solve it. I'm like blown away that you can do this and that it's going to solve from here. So, I mean, it's a 1 or a 2, right? I have a hard time believing this could be 4, but it actually makes sense. That could be 1, 3. And then this would be 2, 2, and that's 1. Now this couldn't be 2. That would have to be 3, 1. It probably breaks because of, I don't know. I'm bad at this, visualizing it. That would have to be a 2, and that would have to be a 2. So that would be, forgive me, this feels very bifurcated to just like solve it until it breaks. But I feel like I run out of this, this would be the 1, so that would have to be the 3. So then that would have to be a 1, but then that's 1, so that's 3. Maybe it does work. I don't know. Maybe it does work. Okay. So probably there's just like irregular Sudoku I could do. So like this digit is that digit. Oh, that's the way to think about it. Duh. Just by irregular Sudoku, this digit has to be that digit, and those digits are on a zipper line, in like the opposite points of a zipper line. So this has to be an even digit. So it is 4. So every way that I was thinking about doing it is actually 4. So 2, 2, 1. Now this becomes 3, 1, 3, 1. Yeah, that's cool. Right. So this is 4, 5. Okay. There's a 4 over here. Okay, where does 1 go in this region? It goes there exactly. We need, why am I so bad at this? 1, 1, 1. Okay, all of those C1. Sorry, that was the explanation for what's going there. Do I have all the 1s? I think I do. 2s. 2s. I mean, do I just pencil mark the whole thing? Just being bad. I'm bad at Sudoku. That was really cool though. 3s are forced. Right. Let's find the 3s being forced. There. So that's a 3, which means that's the 3. And is that all the 3s? That's all the 3s. Okay. So are we thinking 4's in one of those? This is a 4, 5 pair, which means that's a 2. That's a 4 or 5. There we go. 5, 4. So that's got to be the 4. And that's the 2, 5. Wow, that's really cool. That was fantastic. I love that. That was so cool. I cannot believe that you could do that, to be honest, with just these starting marbles, to even just forcing the run, 2 or 3 in the corner. But then to have all of the regions come out spelling zippy to clue that it's a zipper line, and then that solves. That's wild. That's wild. Okay.